third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live. Tonight on The Future of Everything, we've got 3i Atlas updates and maybe even our best shot yet to clearly see the third interstellar object ever detected passing through our solar system.
Far beyond the orbit of Jupiter, in the deep black where the sun's warmth is little more than a whisper, something extraordinary occurred. The interstellar object known as 3i Atlas, a traveler from another star system, became the stage for one of the most electrifying cosmic events ever observed. What astronomers saw defied every expectation, a sudden violent flash that made the object blaze like a miniature sun, glowing with the intensity of a nuclear reactor. For a brief, surreal moment, an icy body drifting through the void transformed into a spectacle of radiant fury, as if the universe itself had struck a match in the dark. Before we start, smash the like and subscribe buttons for more updates. The first signs of something amiss came from automated survey telescopes sweeping the outer solar system. 3i Atlas had been cataloged as a faint, unassuming wanderer, its path traced as it coasted silently on an elongated trajectory from the interstellar void. Yet one night, its brightness spiked by several magnitudes in seconds, not days or hours, but seconds. Instruments recorded a burst of light so intense that it saturated detectors designed to capture faint glimmers from distant worlds. Astronomers scrambled to confirm the reading, suspecting a glitch. But when independent observatories across the globe registered the same event, disbelief gave way to awe. Something enormous had struck 3i Atlas with unimaginable force. Unlike the gentle cometary outgassing that had once been associated with the object, this was a cataclysmic impact. A kinetic assault that ripped through its structure and released energy on a colossal scale. 3i Atlas, a relic of another sun, had met something massive enough to punch through its outer crust and ignite a chain reaction of heat, radiation, and fragmentation. The glow wasn't a trick of reflection, it was self-luminous, a product of atomic fury. Whatever had collided with it unleashed a cascade of energy that rivaled the brilliance of the brightest supernova remnants, but on a miniature, eerie scale. The object itself, long thought to be composed mainly of frozen volatiles and interstellar dust, became an inferno. Observers reported a spectrum dominated by ionized metals, with streaks of exotic elements that hinted at a composition never before seen in our system. The heat radiating from the impact zone was so intense that it vaporized surrounding material, creating a shimmering halo that expanded outward like the corona of a star. For the first time, astronomers were witnessing an interstellar collision in real time, the meeting of two travelers in the dark, one from beyond the sun's reach and the other possibly a wayward object from our own cosmic neighborhood. The scale of the event was staggering. When the kinetic energy of the impact was estimated, it rivaled the combined power output of 1,000 nuclear detonations. The calculations painted a picture of an object perhaps several hundred meters across, an asteroid or remnant fragment that had crossed paths with 3i Atlas at hypervelocity. At such speeds, even a small mass could deliver devastating energy upon impact, compressing material instantaneously to temperatures and pressure sufficient to trigger nuclear-like emissions. The sudden glow was not from fission or fusion in the conventional sense, but from the intense excitation of atoms stripped bare of their electrons, plasma roaring into existence in the vacuum of interstellar space. For a brief span, 3i Atlas was no longer a faint dot on astronomical charts, but a beacon. Instruments from ground-based observatories to orbiting telescopes registered the flare, while radio arrays picked up a burst of electromagnetic noise that rippled through frequencies in ways eerily reminiscent of man-made reactor signatures. The analogy wasn't lost on scientists. What they were witnessing looked in every measurable way like a reactor core running wild in the cosmos. The brilliance persisted for hours before fading to a dull red ember, but the afterglow lingered, a radioactive whisper in the void. What struck researchers most was not just the violence of the event, but its implications. 3i Atlas, like its predecessors 1i/Oumuamua and 2i/Borisov, had come from the stars. Its composition carried the fingerprint of alien chemistry, materials forged in a different stellar nursery. The collision had cracked open a cosmic fossil, exposing its interior to scrutiny in ways no mission could have achieved. Spectral readings suggested elements and isotopic ratios inconsistent with anything found in our solar system. There were traces of rare metallic compounds, crystalline silicates altered by centuries of cosmic radiation, and even signs of superdense material that hinted at prolonged exposure to neutron-rich environments. Each reading was a clue, each spectral line a whisper from another world. The light that radiated from 3I Atlas wasn't uniform. It pulsed in irregular intervals, as though the object itself were breathing, cooling and reigniting in waves of thermal convulsion. This suggested that the impact had not merely vaporized material, but had driven internal reactions, releasing pockets of trapped gases and volatile substances under immense pressure. The rotating fragments emitted jets of plasma that spiraled outward like luminous arms, painting delicate filigrees across the dark canvas of space. To observers, it was both beautiful and terrifying, a ballet of destruction illuminated by the raw energy of cosmic collision. Scientists soon began constructing models to understand how such an impact could have occurred. The interstellar void is vast, and the probability of two bodies colliding in such emptiness is vanishingly small. Yet in the chaotic outskirts of our solar system, in the region of the scattered disk or Oort cloud, gravitational perturbations can hurl objects into intersecting paths. Perhaps 3I Atlas had brushed close enough to the sun's gravitational well to cross the path of a long-lost asteroid or rogue planetesimal. The angle, velocity, and timing aligned in a cosmic lottery that ended in an explosion of light. It was as though fate itself had orchestrated a demonstration of celestial violence for human eyes to witness. The visual spectacle drew comparisons to classic astrophysical events, miniature analogs of supernovae or gamma-ray bursts. But this was no distant cataclysm millions of light-years away. It happened within our cosmic backyard, on the scale of an interstellar messenger that had once passed unnoticed among the stars. The event allowed humanity to observe, for the first time, how objects from different stellar systems might interact physically, how alien material behaves when subjected to energies and forces familiar only in the crucibles of stars. It blurred the boundaries between cometary physics, nuclear processes, and planetary science, forcing researchers to rethink what cold interstellar matter might truly contain. The luminosity curve of the event was unlike any recorded cometary outburst. Most comets flare due to sublimation, sunlight heating ices that vent gas and dust. But 3I Atlas glow was sustained by thermal and radiative processes completely disconnected from solar input. It emitted in hard ultraviolet, in X-rays, and even in low-level gamma radiation, signatures of ionization and high-energy transitions. Some theorists proposed that the impact had struck a pocket of exotic ices laced with radioactive isotopes or complex metallic hydrogen. Others speculated the collision had catalyzed a phase transition in compressed matter, a release of stored energy akin to cracking open a star's forgotten ember. The data became the obsession of the astronomical community. Each observation revealed new mysteries. The shockwave from the impact propagated through 3I Atlas in measurable vibrations, detected as subtle fluctuations in brightness over time. This allowed scientists to infer its internal structure, like performing a seismic scan on an alien world. The results were astonishing. The object wasn't a loose rubble pile, as many expected, but a dense, stratified core wrapped in layers of volatile ice. Such organization hinted that it had formed in a stable, mature planetary system, one capable of creating differentiated bodies, much like Earth. Somewhere long ago, around another star, this object had been born, shaped, and then exiled into the interstellar dark. When the impact occurred, those ancient layers peeled back, each revealing a different story of its origin. There were traces of nitrogen-rich ice, suggesting a cold outer formation zone, alongside crystalline silicates, the products of intense heat and pressure. Embedded grains of metal carried isotopic anomalies that could only have arisen near supernova events, meaning the system that birthed 3I Atlas had been enriched by the ashes of dying stars. It was as if a fragment of another galaxy's history had exploded open before our eyes. The sudden brightness also provided a unique opportunity to study the behavior of interstellar dust and plasma. As material evaporated from the impact site, it created a temporary magnetosphere, a glowing cocoon of charged particles that interacted with the solar wind. Instruments detected distortions in the surrounding magnetic field, hinting at powerful currents flowing within the expanding debris. The plasma behaved unpredictably, forming spirals and filaments reminiscent of auroras or fusion plasma confined within magnetic traps. It was as though nature had momentarily built its own reactor, fusing heat, light, and magnetism in a cosmic laboratory. The scale of energy release raised provocative questions. Could such impacts be responsible for transient luminous events in deep space that astronomers have misclassified? The brightness of 3I Atlas briefly mimicked the optical signature of a small nova, though the mechanism was entirely different. If interstellar collisions are more common than assumed, especially between rogue bodies traveling between systems, they might explain some of the mysterious fast optical bursts that have puzzled astrophysicists for years. 3I Atlas, in that sense, could be the Rosetta Stone for understanding an entire class of previously misunderstood cosmic phenomena. The absence of an immediate explosion or fragmentation debris puzzled some observers. While much of the surface material vaporized, a significant portion of the object appeared to remain intact, though glowing. This suggested that the impactor had penetrated deep into 3I Atlas, embedding itself rather than shattering the whole body. Some theorists posited that the colliding object might have been metallic, perhaps an iron-rich asteroid, which on impact melted and fused with the interstellar material. The resulting composite core could have acted like a containment vessel, temporarily sustaining temperatures and pressures reminiscent of reactor conditions. The nuclear glow, then, wasn't from radioactive decay, but from plasma trapped in electromagnetic confinement, a naturally occurring fusion chamber adrift in the void. Astronomers began referring to the phenomenon informally as the reactor event. The term captured both the intensity and the mystery of the glow, which behaved like a controlled burn rather than an uncontrolled explosion. The sustained emissions suggested a balance between energy release and radiative cooling, as though the system had achieved a transient equilibrium, a fleeting harmony between chaos and stability. For hours, perhaps days, 3I Atlas functioned as a cosmic engine, radiating power into space before finally subsiding back into darkness. The light curve also revealed intriguing periodicities, rhythmic flickers that might correspond to the object's rotation or internal oscillations. Some analysts compared the signal to pulsar emissions, though vastly weaker and slower. Could the collision have magnetized the remnant, turning it into a rotating electromagnetic beacon? If so, it might continue broadcasting for months or years, an artificial-seeming signature born entirely of natural violence. Deep space radio observatories train their dishes on its coordinates, eager to detect any repeating patterns that might betray ongoing interactions between charged particles and magnetic fields. The event carried implications far beyond curiosity. It provided the first direct evidence that interstellar objects can experience transformative collisions within our solar system, events capable of reshaping their composition and even their trajectories. If such impacts occur more often than imagined, they could be a major mechanism for transferring material between systems. Fragments from 3I Atlas might now carry traces of both alien and solar system chemistry, drifting onward to seed future worlds. The concept of panspermia, the transfer of life's building blocks across space, gained new relevance. If biological precursors can survive inside such bodies, collisions like this could spread them from star to star, turning the galaxy into a web of chemical exchange. The scientific community marveled at the serendipity of observation. Interstellar objects are rare and fleeting. Most pass unnoticed before vanishing into darkness. To witness one struck so dramatically was like catching lightning in a bottle, an astronomical miracle. Observatories worldwide coordinated to study every wavelength of the event, from infrared signatures of cooling dust to ultraviolet spikes marking ionized gas. Each instrument added a new layer to the picture, revealing that what began as a single blinding flash had become a complex cascade of physical phenomena spanning the electromagnetic spectrum. The glow's persistence surprised even the most optimistic models. Instead of fading rapidly, it maintained a steady luminosity for far longer than expected. Some speculated that internal reactions, possibly involving metallic hydrogen or other exotic states of matter, continued feeding the emission. If true, 3I Atlas might represent a new class of object altogether, interstellar reactor remnants, bodies whose collisions ignite internal feedback loops that sustain radiant energy for extended periods. Such phenomena could account for certain mysterious glowing bodies detected in deep interstellar space, whose light cannot be explained by fusion, reflection, or decay. The spectacle also rekindled philosophical wonder. Humanity, watching from its fragile cradle of stone and atmosphere, had witnessed the cosmos performing an act of pure, unchoreographed creation, or perhaps destruction. The event blurred distinctions between the mechanical and the miraculous. It reminded observers that the universe is not static, but alive with energy, motion, and unpredictability. In one blinding instant, 3I Atlas had become a storyteller, its tale written in light, carrying secrets from another sun into our night skies. The implications rippled through scientific disciplines. Astrophysicists saw in it a model for energy transfer and plasma dynamics. Planetary scientists glimpsed the birth of hybrid bodies that bridge interstellar chemistry. Cosmochemists found clues to the processes that distribute rare elements across the galaxy. The collision also offered a preview of what might occur when rogue planets or moons stray too close to alien debris fields. A small-scale version of the cataclysms that once sculpted early solar systems. For a few hours, humanity had a window into the raw mechanics of creation itself. From a purely observational standpoint, the event challenged assumptions about interstellar object fragility. Many had assumed such wanderers, having endured eons in deep space, were little more than dusty aggregates ready to crumble at the slightest perturbation. Yet 3I Atlas absorbed an impact of apocalyptic magnitude and still retained structural coherence. This suggested remarkable tensile strength or perhaps unknown binding mechanisms, electrostatic or magnetic cohesion on a scale unseen in typical cometary material. It hinted at physics yet to be fully understood, at materials formed under alien conditions beyond our comprehension. The analysis of the post-impact spectrum provided even more surprises. Some emission lines corresponded to isotopes that are unstable under normal conditions, materials that shouldn't persist for long in open space. Their presence implied either continuous generation through energetic reactions or reservoirs deep within the object, shielded for eons until the impact exposed them. Among them were hints of rare transuranic elements, though the data remained inconclusive. If verified, their existence would revolutionize understanding of nucleosynthesis beyond the known periodic table, suggesting that alien stars, with different pressures and temperatures, might forge matter unknown to Earth. The faint echo of that violent impact continued to ripple across the void long after the light faded from human instruments. Deep within the fractured remains of 3I Atlas, unseen forces still stirred. Beneath the layers of scorched silicate and frozen gases, something was happening, an aftershock of physics too complex to end with the first blinding flash. The collision had not simply broken the object apart, it had transformed it. What was once a drifting relic of a foreign star system was now an alchemical crucible, its interior reforging itself under the relentless pressures and temperatures unleashed by that cosmic strike. Inside the newly fused core, the material was neither solid nor liquid, but something in between, a plasma glass hybrid, roiling with currents of ionized particles. The immense energy from the impactor's kinetic release had melted metal-rich inclusions and turned volatile ices into a superheated envelope of gas. This mixture was trapped within magnetic fields spontaneously generated by the violent flow of charged matter, creating a feedback loop that continued to sustain faint radiation. Even in the darkness where no sunlight reached, 3I Atlas glowed from within like a dying coal refusing to go out. Every rotation of the object revealed subtle shifts in its luminescence. To human eyes, it would have been invisible, but sensitive instruments aboard distant probes could detect the faint rhythmic pulses. Each flicker marked a slow, uneven heartbeat, the rhythm of matter cooling, compressing, and restabilizing after chaos. Though the brilliant blaze had faded, a soft phosphorescence lingered, powered not by fusion or radioactivity but by persistent ion recombination. The atoms, torn apart by the shockwave, were slowly finding each other again, and every union released a whisper of light. The impact had also reshaped the body itself. Its once ellipsoidal form was now irregular and bifurcated, as if two worlds had merged. One half bore the jagged crater where the intruder had struck, and the other stretched outward into a plume of solidified ejecta, frozen arcs of molten rock that had cooled in vacuum. The scars told the story of compression and ejection, of impossible temperatures frozen in mid-motion. Some regions gleamed like polished obsidian, their surfaces fused into glass by heat, while others were latticed with fractures where vapor had escaped. These were the physical inscriptions of the event, geological hieroglyphs written across the skin of a wandering world. Microscopic analysis of the spectral data hinted at something even stranger: molecular restructuring. The intense energy flux had driven atoms into configurations impossible under normal circumstances. Silicon, carbon, and metal atoms bonded into exotic lattices that did not conform to known crystalline orders. Some of these structures exhibited photonic properties, materials that manipulated light in ways that only advanced human laboratories could imitate. For a moment, nature had performed a form of cosmic nanotechnology, using shock and heat to forge materials that could bend radiation and reflect magnetic flux. These products of chaos would drift for eternity, silent witnesses to the creative violence that had birthed them. The expanding debris cloud around 3I Atlas became a region of scientific obsession. The fine particles ejected into space glowed faintly in the infrared, their heat signature gradually declining but remaining measurable. They stretched into a ribbon hundreds of kilometers long, forming a diffuse trail that trailed the body like a comet's ghost. Each particle carried within it the memory of its creation: isotopic ratios, frozen wavefronts of plasma cooling, and entrapped magnetic domains recording the fields that once raged there. Spacecraft with distant sensors captured faint radio reflections from the debris, allowing scientists to map its structure in unprecedented detail. Within that data lay hints of rotational acceleration. The entire object had begun to spin faster after the collision. Conservation of angular momentum demanded it. As mass was ejected, the remaining core gained rotational energy. Its spin period shortened from days to mere hours, creating stresses across its surface. Cracks opened as centrifugal forces strained the already fragile crust, releasing new puffs of vapor that shimmered in ultraviolet light. Each venting was like an exhalation, carrying away heat and fragments of its past. The universe had turned the object into a gyroscopic ember, slowly tearing itself apart as it tried to balance its newfound motion. The environment surrounding it became a microcosm of plasma physics. Charged particles streaming from the solar wind interacted with the magnetic fields generated by the rotating body, creating miniature auroral effects. Twisting arcs of energy encircled the object, invisible to the eye but visible to sensors tuned to the right frequencies. These ghostly halos pulsed with variations in charge density, forming transient loops and filaments that stretched for hundreds of kilometers before dissipating. To an observer nearby, the spectacle would have resembled an ethereal web of living light, the product of pure electromagnetism dancing upon the remains of a shattered world. As weeks passed, 3I Atlas began to drift further into the outer regions of the solar system. The sun diminished behind it, and the temperature of the remaining gases plummeted to near absolute zero. Yet the radiation signature refused to vanish entirely. Embedded deep within the object, beneath kilometers of fused crust, sensors detected an internal heat source, faint but steady. Some theorists suggested this could be due to trapped radioactive isotopes exposed during the impact. Others proposed a subtler mechanism: piezoelectric heating, caused by ongoing deformation of crystalline structures as the body spun. Each flex and twist of the fractured layers generated electric currents, small in magnitude but constant, feeding a persistent glow that no one had predicted. This glow was not mere remnant heat, it was an ongoing process. The internal pressures and electric currents were converting mechanical stress into electromagnetic energy. The object had, in essence, become a natural generator, a battery of planetary scale born from collision. It transformed motion into radiation, sustaining its luminescence long after the violence that had created it ceased. Such self-sustaining conversion hinted at a previously unknown mode of energy retention among celestial bodies. If other interstellar objects had experienced similar collisions during their long voyages, they too might harbor hidden currents, glowing faintly in the dark between stars. The more scientists studied the data, the clearer it became that 3I Atlas was no longer simply an interstellar rock. It had become a hybrid entity, part remnant, part machine of nature's making. Its thermal oscillations followed patterns that seemed almost algorithmic, sequences of heating and cooling that repeated with mathematical precision. Though entirely natural, the rhythm appeared intentional, as if dictated by internal resonance phenomena balancing stress and relaxation. These patterns fascinated astrophysicists because they hinted at self-regulation, a property rarely associated with inanimate bodies. The object behaved as though it sought equilibrium through cycles, each one radiating away the chaos born of the collision. In the months following the impact, instruments recorded another unexpected feature: the faint emission of radio waves in a narrow, repeating band. These emissions were weak but distinct, modulating with the object's rotation. The frequencies corresponded not to random noise, but to harmonic resonances generated by the interaction of charged plasma streams around its magnetic field. It was, in effect, broadcasting a natural beacon. Though there was no intelligence behind it, the signal carried information about its spin rate, magnetic intensity, and energy fluctuations. Space physicists joked that the universe had accidentally built its own transmitter, using a collision instead of circuitry. The energy output, while small by cosmic standards, remained steady enough to suggest that deep chemical reactions might still be occurring within. As the molten core cooled, pockets of volatile gases likely recombined into new compounds, releasing bursts of heat in the process. These reactions could persist for centuries, slowly transforming the composition of the interior. The impact had mixed materials from different origins, creating an unpredictable chemistry of alien and solar matter. The result was a laboratory of cosmic synthesis, where elements forged around another star mingled with isotopes born in hours, forming compounds that had never before existed in the universe. In one of the more speculative interpretations, some theorists argued that collisions like the one involving 3I Atlas might act as catalysts for interstellar chemical evolution. When bodies from different star systems collide, their unique chemistries merge, potentially creating complex molecules under extreme conditions. These molecules, once ejected into space, could seed new planetary systems with diverse materials. Over eons, such exchanges could homogenize the galaxy's chemical inventory, spreading not only elements, but also the building blocks for life. In this sense, 3I Atlas was more than a spectacle. It was a participant in the grand alchemy of the cosmos, where destruction becomes creation. The collision also opened new discussions about interstellar object dynamics. Previously, such travelers were thought to drift inertly through space, altered only by gravity and radiation pressure. The Reactor event, as it became known in scientific circles, suggested that these wanderers could undergo transformative episodes that change their composition and motion dramatically. Each collision, each burst of light, could turn a cold relic into a temporary star, rewriting the object's identity before it continued on its journey. The idea that the galaxy is peppered with such transient illuminations, flashes of interstellar bodies colliding and igniting, added a new dimension to our understanding of cosmic evolution. As 3I Atlas receded into the darkness, astronomers began to notice faint ripples in the surrounding space environment. The impact's energy had not been confined to light and heat, it had also generated gravitational perturbations, subtle distortions detectable in the trajectories of nearby dust and small objects. These ripples suggested that the collision's momentum exchange had altered the local gravitational field, if only slightly. It was a reminder that even on a small scale, impacts can influence the architecture of space itself, nudging invisible currents of matter and energy in directions that may resonate for millennia. Within the data streams of those months, another discovery emerged, one that challenged even the most conservative analysts. The magnetic field around the object exhibited a persistent polarity reversal pattern, switching orientation every few days. This oscillation resembled the magnetic cycles of stars or planets with molten interiors, yet 3I Atlas was far too small for a traditional dynamo mechanism. The explanation lay in the interplay between its spinning conductive materials and the trapped plasma envelope around it. The plasma currents acted as a moving conductor, generating alternating magnetic fields as they drifted relative to the core. In essence, the impact had created a miniature magnetosphere that pulsed with lifelike rhythm, its invisible heartbeat echoing through the surrounding void. This magnetic dynamism opened new speculation about how such phenomena could influence interstellar navigation. Hypothetically, advanced civilizations might detect and study these natural beacons as markers of collision-rich zones, regions where interstellar bodies exchange matter and energy. Each glowing remnant could serve as a timestamp of galactic history, an event frozen in radiation that tells of encounters between systems long separated by light years. 3I Atlas, through sheer chance, had become a lighthouse in the cosmic sea, its faint pulse carrying across distances where light alone often fades into silence. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I Atlas glowing like a nuclear reactor after impact? We want to hear from you. Thank you for watching, and see you next time.